Okay, this is the last video, and this will go through 16 through 25, so this will probably be a little bit longer video. Okay, this is doing substitution, so ugly substitution, so I'm going to look at it that way. I'm going to let u equal the square root of 2x plus 1, because that's what looks the same right here as kind of the ugly stuff. So we've got u is equal to 8 over u plus 2. Now multiply both sides by u, just to clear fractions, so u squared equals 8 plus 2u. I need to move everything to one side so we can factor it. So u squared minus 2u minus 8 equals 0. This is u minus 4 and u plus 2. So either u equals positive 4 or I get u equals 2. Now if u equals 4, u equals negative 2. Make a correction to that. If u equals 4, well now I'm going to plug in. I get square root of 2x plus 1 equals 4. We'll square both sides. 2x plus 1 equals 16. 2x equals 15, so x equals 15 over 2. There's one answer. Then we have u equals negative 2. Square root of 2x plus 1 equals negative 2. Now you have to be careful, because there's no way I can get a negative out of a square root. So this doesn't have a solution. Now if you go through and you solve it and you plug in and check, you'll find it doesn't work. But you have to be extra careful. So this can't happen. Therefore, my answer is only E. Now, for question 17. Again, working for the inequalities. First step I'm going to do is subtract 9. So I get negative 39. I'm just going to change this to equals. Divide by negative 3. 13 is equal to the absolute value of 3 minus 2x. If you see a negative here equaling absolute value, it's a special case. It's either all numbers or no solution. Then you just plug in any number you want, usually 0, and see if it's true or false. If it's true, it's all numbers. If it's false, it's no solution. This is a positive, so I got to go through two cases. So 13 is equal to 3 minus 2x, and I'll do negative 13 is equal to 3 minus 2x. So solving, I get 10 equals negative 2x, so x equals negative 5. I get negative 16 equals negative 2x, so I get x equals 8. Then I'm going to do a number line, and now I'm going to go back to my original equation. We had negative 5, we have 8. Now, it's either going to go true, false, true, or false, true, false. So I'm going to plug in 0 to see if it's true or false. Plug in 0. Negative 30 greater than 9 minus 3. 3 minus 0, this is 3. So I get 9 minus 9. I get negative 30 greater than 0. That is false. So this area right here is false. Now I could plug in 9, I could plug in negative 6. I am going to see that these are true. So I get x is less than negative 5 or x is greater than 8. Okay, 18, solving. So first thing I'm going to do is get the 1.05 to the x by itself, so we'll add 100. So 2 times 1.05 to the x equals 600. We get 1.05 to the x equals 300 by dividing. Now I'm going to take the log of both sides. It's x log 1.05 equals log of 300. Basically applying my log rule. When I take log of both sides, I get log of 1.05 to the x. I move the x out to the front. Then if I was to solve it, it'd be log of 300 over log of 1.05. Okay, we're going to find our roots. This one's kind of sneaky because it looks like it factors, but it doesn't. So, use quadratic formula. You have negative 4 plus or minus b squared is 16 minus 4 times 1 times 5 all over 2 times 1. Well, at 16 minus 20, that's negative 4. Square root of negative 4, that's going to be 2i. So I get negative 4 plus or minus 2i over 2. Reduce them all by 2. I get negative 2 plus or minus I. So negative 2 plus I and negative 2 minus I. Okay, we have another substitution problem here. So I'm going to let u equal x squared minus 1. Okay, so when we go to solve this, I've got u squared plus 24 equals 11u. Move everything to one side, get u squared minus 11u plus 24. This factors to u minus 8 and u minus 3. So I get u equaling 8 and u equaling 3. So that means I've got 8 is equal to x squared minus 1. I get 9 equals x squared. We take the square root of both sides, and it's plus or minus 3 is equal to x. So I know that A and E work. Got to make sure there's no other ones. So now I'm going to do set an equal to 3. 3 equals x squared minus 1. 4 equals x squared. I get plus or minus 2 equals x. I don't have those choices. If 2 and negative 2 were on that list, I'd be circling those as well. So you got to be careful, make sure your answers are actually there. Okay, this one, you can't solve algebraically. Only way to do this one is by graphing or guess and check. But think about the graphs. Y equals 2 to the x. Y equals x plus 4. Intersects at 2 spots. It's going to have 2 solutions. Now, other graphs you should probably know. You should know what the graph of y equals log base 2 of x. That graph looks like this. You should know what graphs of lines are, parabolas, circles, all the other ones. But this one, sometimes you could see that same problem come up in that kind of a situation. Okay, inequalities. I'm going to move everything to one side. So I've got 2x cubed minus 4x squared minus 16x. And adding and subtracting does not change the sign, so it's going to be greater than 0. And you could change to equals and then deal with testing your regions afterwards. I'm going to factor out a 2x. Now I'm going to factor out the quadratic in here, or the parabola in here. So I have x minus 4, x plus 2. So it's going to equal 0 when x equals 0, x equaling 4, and x equals negative 2. I'm going to build a sign chart. X equals 0, negative 2, positive 4. If I plug in a number bigger than 4, all these are positive. If I plug in like 1 into the equation, I get 2, I get negative 3, positive 3. positive times negative times positive. This one's negative. Now what you should anticipate is it alternating signs unless you have a square. If you have a square, it's going to repeat. But I should have alternating signs. If I plug in 1, I plug in -1, I get -2 times -5. So negative times negative is positive. -1 plus 2 is a positive. That one's positive. And if you checked with -3, we'll see that one's negative. They're all going to be negative. I'm looking for where it's greater than 0. So I'm looking for the positives. So I get -2 is less than x less than 0, or x is greater than 4. So I want to know all the ones that actually work. Well, that's this one and that one. Okay, this one's about factoring. Now this one gets a little intimidating because it's not your normal kind of thing. You can't factor out an x, but you should realize this is basically like a quadratic. To get x to the fourth, that's x squared times x squared. So I've got x squared. To get -3 in the middle from -4, I get x squared minus 4, x squared plus 1. This will give me -4x squared plus x squared is -3x squared. This factors to x plus 2, x minus 2, x squared plus 1. So my factors, well, x squared plus 1 is a factor. That's just a term, the x squared. You might look at that, but you can't even factor out an x squared. We have x minus 2, and none of the other ones work. On 24, now if you have a hard time counting what the numbers are, just look over here. I see 2s and 5s. So I'm going to be shifting 2 and 5, either right 2, left 2, up, or up and down 2, and vice versa with 5s. So if I look at this, I can see that this graph got shifted to the right 2. So this is right 2, and that means the other one is the 5. And I can see it went down, so it's going to be down 5. Just in case you have a hard time. You should be able to count it out also with the squares, just in case you have a hard time reading it. Okay, right 2, we do the opposite. So right 2 is in the positive direction, we got to do x minus 2, and down 5 would be minus 5. So I change the x with the minus 2, then the down 5. Okay, last one. Okay, probably the easiest way to do this one, let it equal x, and I got 1/2 raised to the x equals the square root of 2. I'm going to try to match bases here because you don't have a calculator to build. I take log of both sides. So I get 2 to the -1. So I get 2 to the negative x equals 2 to the 1/2. So I get negative x equals 1/2. X must equal negative 1/2. And that's our last problem.